Hi, Jeffrey, Jonathan, and Dan. Today we're learning about circles and arcs. So just a little refresher here. I know you mostly know this stuff, but P is called your center, AB is your diameter, PC is your radius. And the only new part here is that this right here is called your central angle. And a central angle can be any angle whose vertex is the center. So it doesn't have to be that exact one, but you would angle PAPC is a central angle. And CPB could be a central angle. And actually APB, that semicircle, could be a central angle. So that's the first piece we need to get down. The next thing is we're going to talk about arcs now. And when we're talking about arcs on a circle, if it's a minor arc, that's a less than 180 degrees, you just use 2 points to label it. Okay, so I could say arc, let's see here, RS. So I would just pick those 2 points and you put a little arc above it. Arc TS. Arc MT. And the major arc would use 3 points and it would be more than 180. So we could do something like TMR. Or do you guys see another one? How about SRM? Okay, so those are some examples of minor and major arcs. Semicircle can be labeled with 2 because they're directly across from each other. So when you go to the other, it doesn't matter which route you take. See, in this one, you want to make sure the major arc, you have that middle point. Otherwise, if you went just TR, you could have taken the shortcut. But when you're saying a major arc, you need that middle one so you know to go the long way around. Okay, I'm going to turn my table a little, see if my shadow can go away here. Oopsie, whoa, oh dear, hang on. Okay. All right, so let's take a look here at arc measure. It's kind of hard to see that, but it's basically telling you that the angle measure of the central angle here, which it says it's 50, is also the measure of the arc, RT. So as you can see, it shows that right here, measure of RT is equal to the measure of the angle RST. So both of them are the same. Okay, and that only works, again, when that S is right in the middle. Okay. All right, so what are adjacent arcs? Well, adjacent arcs are arcs that have, and you can't see what I'm writing, so that's a problem. Let's move that down. Arcs that have 1 point in common. Okay, so then we get to the arc addition postulate, and it's exactly what it says. If you take 2 adjacent arcs, so let's see here, let's take AB, and you add to it the arc, I'll put the little M in there, BC, then it's going to equal the arc ABC. Okay. So pretty much common sense, but we're talking then again about the arcs. Okay? All right, let's take a look at the second page here. So when we look at the top and it says what is the measure of each arc in not OC, that's circle C. I'm like, that doesn't make sense. Okay, in circle C. So go ahead and I'm going to give you just a minute here. You guys go ahead and try to write down what you think they would be. If you're not done, go ahead and pause the video and then start it up after you get all 4 of them. I think I should do that instead of just waiting. So, all right, so we have 77 here, and we can see that this is a diameter going across. 180 minus 77 leaves this one to be 103. Okay, and since this arc is 28 degrees, this angle is 28 degrees. And then we can take this, subtract it from 180 or 360, either way. And we are going to end up with, I don't know, what is that going to be? 180 minus 28 is 152. I mean, if we have all those, we can get any arc we want. So PR, arc PR is going to be the same of its central angle, 77. Measure of arc RS is going to be 103. The measure of PRQ, PR to Q, is going to be these three added together, or 360 minus the 152. Either way, it should come out to 208. And PQR, PQ, and R, going the long way around, 360 minus the 77, or you could add these together, which I think is the longer way, but that should be 283 degrees. So hopefully you guys got those right. Couple reminders. I mean, these are things you know, so I just am tagging them out here. Circumference pi times diameter, and remember diameter is the same as 2 radiuses, so you can use either formula. And that pi is an irrational number. So if I tell you to leave it in terms of pi, or tell you, that would mean that you have a pi in your answer. If I say to give me the exact answer, okay, hang on, there we go. If I tell you to give you an exact answer, then pi should be in your answer. You are only plugging pi into your calculator, which you should use the pi button to get the most accurate approximation, but that is exactly what it is. It's an approximation. Coplanar circles are circles that have the same center. Okay, so actually I don't think it's coplanar, I think it's concentric. Did I write that down wrong? I don't have my book here, but I'm pretty sure it's concentric. So when you are looking at a problem like this, it says a car has a circular turning radius of 16.1. So that's the radius. And the distance between the two front tires is 4.7. So basically this radius is 4.7. Not radius, that distance. How much farther does a tire on the outside travel than the tire on the inside? So basically, right, you need to know this distance, because that's going to be the inside one, and you need to know this outside distance. Okay, so we need to get two circumferences here. So we'll do the circumference of the small, which is pi times diameter. And what is the diameter of the small one? We don't know that, do we? Well, we can get it. 16.1 minus 4.7, 11.4. So we now know that is 11.4. Ah, but that is only the radius. So we have to double that, and we get 22.8 pi. I think I messed that up in my work here. What's wrong with me? Okay. So then we need to get the circumference of the large one. That's also pi times diameter. Pi times the diameter of the large one. This is the radius, so we would double it. Well, I don't need to do that. It's 32.2. Now what do I do, class? I need to subtract, because it said how much farther does the tire turn. So I've got 32. I'm going to go over here. 0.2 pi minus 22.8 pi. And since there's a pi in both, I can just subtract the numbers. It's kind of like subtracting a 32x minus a 14x, that kind of a thing, because it's the same. So you're basically using distributive property to factor that out. And 32.2 minus 22.8 is what? And a 9.4 pi. for my answer, but I would almost like to know what that is in real time, and it comes up to 29.5 feet, about. That's an approximation again. This is exact. This is an approximation. All right. Questions on that? Boy, you guys are awfully quiet today, aren't you? All right. So what is the length of a semicircle with a radius of 1.3? Oops, we missed something here. Arc length. Boy, I'm not on the ball here. I think it's because it's almost 9 at night. All right. The length of an arc of a circle is the product of the ratio. Oh, okay, right. So if you need the arc length of part of the circle, like let's say that part, and let's say you knew this degree measure right here. Well, that's the amount of the circle, right? So let's say it's 50 degrees. You can do 50 out of the total of 360. That's the how much of the circle is right here, right? And then you can multiply that by the circumference. 2 pi r, pi times diameter, whatever. And that's how you're going to get an arc length. That will tell you the distance from here to here. So what is the length of a semicircle with a radius of 1.3? Semicircle, of course, is halfway around. So that's 180 degrees, which reduces to a half, doesn't it? So it's a half of the circumference. Okay, so a half of gives us the radius. So I'll use the 2 pi times 1.3. And it works slick because the 2's cancel, and we're left with 1.3 pi. And it does say leave answer in terms of pi. So I just need my unit, and we're all set. All right, boys, hope you have a great day. Take care.